So hello everyone, welcome to my video for the term project of the calculus 3 course. In this video, we will go through to the discuss of the Stokes theorem. So in the previous chapter, we went over the Green's theorem, which let us turn the line integrals from a closed curve C in two dimension to a double integral over some region. And for in this video, we are going to look at the theorem called Stokes theorem that can be through as a higher dimensional version of the Green's theorem when we have a closed curve in the 3 dimension where the curve is boundary of the surface S. Just as with the Green's theorem, we assume that the curve is positively oriented, which means that the part of the curve goes in the counterclockwise direction with respect to the normal vectors of the surface. Or you can think yourself as walking along the curve, and while you are walking along the curve, if your head pointing in the same direction as the unit normal vector with which the surface is on the left, then you are walking in the positive direction on C. And for now, if we have a vector field far left, permitting space to find the amount of the file that goes in the direction of the curve, we would need to take the line integral of f along C Stokes theorem give us another method of finding the line integral, which can lead to a similar calculation. For the Stokes theorem, that the line integral of f along C is equal to the surface integral, that they aren't too different to solve it. It's just that now we have the extra step of thinking a curve. Probably we know that the curve of the vector phi f is calculated by taking del cross f, where del was the vector d over dx, d over dy, d over dz, which we can use Stokes theorem to calculate the line integral. It can also be used in reverse if we want to find the surface integral of a curve. And the boundary is similar enough to calculate. Now let's look at our example. We are given vector f equal to z square minus x3 xy x cube y cube, and as is the part of the z equation equal to 5 minus x square minus y square above plan z equal to 1. We need to find the double integral of the curve of f dot the normal vectors over surface S by assuming that S is oriented upward. We have our plan z equal 1 and surface C equal 5 minus x square minus y square. So we got 1 equal to 5 minus x square minus y square, or x square minus y square equal to 4 at C equal 1, which is the circle of radius 2 at the level of z equal 1. Therefore, the parameterization of this curve C is a vector r of t equal to 2 cos t, 2 sin t, 1 where st is between 0 and 2 pi by using the Stokes theorem. We know the double integral of the curve of f dot n over surface S is just the line integral of f dot dr over curve C, which is equal to integral from 0 to 2 pi of the vector f of r of t dot r prime to t dr, But for f of r of t is 1 minus 3 times 2 cos t times 2 sine t, 2 cos t cube and 2 sine t cube are equal to 1 minus 20 cos t sine t, and 24 cos cube t sine cube t, and r prime of t is minus 2 sine t, 2 cos t, and 0. So we get the vector f of r of t dot r prime of t is equal to 1 minus 20 cos t sine t and 24 cos cube t sine cube t dot minus 2 sine t, 2 cos t and 0, which is minus 2 sine t minus 24 cos square t sine t. We can get the integral from 0 to 2 pi of the vector f of r of t dot r prime of t dt is the integral from 0 to 2 pi of minus 2 sine t minus 24 cos square t sine t, which is equal to 2 plus 8 cos cube t from 0 to 2 pi. By substitute the values of t at 0 and 2 pi, we got 0. So it means that our double integral of curve from f dot n over surface s is equal to 0 as well. And now we are going to continue on our example number 2. We are giving vector f is equal to z square y square x, and our curve C is the triangle, the vertices of 1 0 0 0 1 0 and 0 0 1. As we can see in the pictures, and it have the counterclockwise orientation, we need to find the line integral of vector f dot with the dr over the curve C. We have curve f vectors. Curl f vector is the del cos f, which is the determinant of vector ijk. Partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z, and c square y square x, which is equal to partial derivative of x with respect to y minus partial derivative of y square with respect to z times I hat minus partial derivative of x with respect to x minus partial derivative z square with respect to z j hat plus partial derivative of y square of y square with respect to x minus partial derivative of z equal with the square with respect to y times k hat, and it is equal to minus of 1 minus 2z times j hat equal to 0, 2z minus 1, 0. We can obtain the equation of the part x as x plus y plus z equal to 1 or 2 is equal to the function g of xy equal to 1 minus x minus y. Basing the Stokes theorem, we got the line integral of the vector f dot the vector dr over curve C is the double integral of curve of f dot ds over surface S. So now on, we got the line integral vector f dot vector dr over curve C is double integral of 0 to z minus 1 and 0. Dot ds over surface S or double integral of 0 to z minus 1, 0 dot grid f over norm grid f time grid f time dA over surface S. Now we need to find a few quantity. First, we need to find grid f. Now let's have our function f of x, y, z is equal to z minus g of x, y, or equal to x plus y plus z minus 1, where is we can get the grid f is just vector 1, 1, 1. As it also pointing up about the about that give us positive orientation, so that it is the correct direction. Now let's say that D is the triangle region in the XY plane that we need to see in the picture. We got the equation of the line as y equal to minus x plus 1 at z equal to 0. Then D is the region defined as set of point xy where x is between 0 and 1 and y is between 0 and minus x plus 1. The line integral of the vector f dot vector dr over curve c is double integral of 0 to z minus 1 and 1 dot 1, 1 and 1 time dA over region D it is equal to the integral from 0 to 1 of the integral from 0 to minus x plus 1 of 2 times 1 minus x minus y minus 1 dy dx, or it is equal to the integral from 0 to 1 of the integral from 0 to minus x plus 1 of 1 minus 2x minus 2y times dy dx. We get the integral from 0 to 1 of y minus 2xy minus y square from 0 to minus x plus 1 times dx. And it is equal to the integral from 0 to 1 of minus x plus 1 minus 2x times minus x plus 1 plus 1 minus of minus x plus 1 square times dx, or we can simplify of the integral from 0 to 1 of x square minus x times dx, or equal to 1 over 3x cubed minus 1 over 2x square from 0 to 1, which is 1 over 3 minus 1 over 2 minus of 0 minus 0, or it is equal to minus 1 over 6. So hence we can consume that the line integral of the vector f dot vector dr over the curve c is equal to minus 1 over 6. So that is all of my video. So don't forget to ask any question that you want or you don't understand in the comment below. If you don't understand it in some part. And thank you for your attention and goodbye.